All right, so here are your directions. I want us to factor this polynomial right here. Okay. By the way, quick review. What's the degree of this polynomial?
3.
3, because that's the highest power that you see. Because it has a degree of 3, the name you would give it is cubic. How many terms does it have? 4 terms. There's no special name for that I really care about, so you can just say it has 4 terms. Okay? Someone guessed the other day quadrinomial or something. I have no idea. Okay? But anyway, it has 4 terms. So we'll review there. Okay, so we want to factor this. You could try factor by grouping, but I know for a fact that that's not going to work here. Okay? I know there's 4 terms, but factor by grouping, you're not going to get common factors, so that's not going to work. So we got to be able to have another way of doing this. Okay? I was kind to you and said 7 is a 0 of this polynomial. All right? Here's the thought process I want you to take. If 7 is a 0, what is one of the factors? Say the entire factor. I know what you mean, but x minus 7. Does that make sense? If 7 is a 0, then x minus 7 must be one of the factors. Okay? So that's kind of my first thought. So x minus 7 is one of the factors. Okay? So then what I'm going to do is I'm going to take what I kind of talked a little bit about yesterday. If I know one of the factors, I'm just going to do some division to help me figure out the other ones. Okay? Remember how I talked about, if we were factoring, well, Bree, of course, just knew it off the top of her head. Okay? But I said, is 7 a factor of 1022? Okay? Well, all right, we don't know that right off the top of our head, but if we know one of the factors, we can divide to get our other ones, right? Okay? For instance, 145. If I said to factor 145, do you know the factors right away? You probably know one factor right away? 5, right? So you know 5 is one of the factors. How would you get the other one? You divide it. Make sense? Okay? So if I know one of the factors, I'm going to divide to try and figure out my other factors. Is that logical? Okay. So I'm not going to do the long division today. I'm going to do that shortcut, that synthetic division again. Okay? So let me show you how we will do that. When you do synthetic division, so right now, we're going to take this and we're going to divide it by x minus 7. So if you want to do this whole thing, if you want to do the long division, the 2x cubed minus 9x squared minus 38x plus 22. If you want to do that long division, you go ahead, but I'm going to do synthetic division because I have a feeling that's what most of you will do. Okay? So when you do synthetic division, you take the 0 and you put it in a little box right here in the top left corner. Then you use the coefficients of the polynomial and you put them just off to the right of that. Speak up with questions as you have them.
What if there are no coefficients?
If there's not a number there, there's really actually a 1 there. It's like if you just saw x cubed, that's actually 1x cubed. Now, that brings up a good point though. Let's say you didn't see an x squared. Let's say you just saw 2x cubed minus 38x plus 22. If you don't see an x squared, then how many x squareds are there? 0, right? Okay, you would need to put a 0 in here because this needs to be in order from the highest power down to the lowest power. So if this said 2x cubed minus 38x plus 22, I would have put 2, 0, negative 38, 22.
What if they were all 1?
What if they were all 1s? Then you have all 1s. Yep. Any other questions? Good questions. You understand the placeholder thing? Because these got to go in decreasing order from the highest power. X to the third, x squared, x to the first, constant. If you're missing a power in there, you got to have that placeholder, so you got to put that 0 in there. Okay? Alright, so here's how you do synthetic division. You draw a line, you take the very first coefficient and you drop it all the way below the line. Then you take that number times what's in the box and put it just underneath the next guy, the next coefficient, and then you add those numbers together. So negative 9 and 14 add together and make 5. And then you just do it again. Take this number times 7, 35, and you... Did I write my problem down wrong? Yes, I did. Sorry, I wrote my problem down wrong. That's going to make for a great video.
It's supposed to be 21.
Yep, that's supposed to be 21. Seven times negative 3 is negative 21. That's how I knew there was going to be an error already, as I was noticing that it wasn't going to finish with a 0. So that's why I had to go back here just a second.
Does it always finish with 0?
If this number is a 0 of the polynomial, I guarantee that last one's always going to be 0 there. Because it's basically, that's like going into it evenly. If you get a number back here, that's actually kind of like a remainder, which would mean it doesn't go into it evenly. Does that kind of make some sense? It's kind of a way to check your work to make sure that it factors correctly. Okay? Alright. Any questions on the synthetic division? Okay? So, alright, well, what do those numbers mean? Alright, well, remember, we started with 2x cubed minus 9x squared minus 38x plus 21. When we divided that by x minus 7, all of the powers decreased by 1. So now I have 2x to the second plus 5x minus 3. See how I just decreased whatever the starting power was. My answer starts with a power 1 less than that. Because anytime you divide, the powers decrease.
Staff, if you need to get your picture taken, you may go at any time this morning. Staff, if you need to get your picture taken, please head to the photographer when it is convenient for you.
So, had we done the long division, this is what we would have got. Same thing that you get by doing synthetic division. Okay? So now what that means is, if I wanted to factor this polynomial, I know that one of the factors was x minus 7, and the other factor is this right here, 2x squared plus 5x minus 3. Does that make sense? Just like with my 145, remember? If I know 5 is a factor, and then you divide by 5, and that gives you 29, then obviously you know that 29 is the other factor, right? But now on this one, this is a bad example. On this one, I'd be done factoring, right? Because 29 can't be factored any further. But let's say this was 28. Then could you factor it further? Absolutely. So that's the same thing going on here, is I know x minus 7 was one of my factors. So when I divided by x minus 7, I got this. But do you think this can be factored further? Maybe. Alright? For speed purposes, I'm going to go ahead and do a little guessing and checking. Okay, because the numbers aren't going to be too bad. But if you needed to, you could do your little box method or however you want to do it. Okay? What times what gives me 2x squared? 2x and x. And then these two numbers do have to multiply to a negative 3, but I'm going to have to make sure that the inners and the outers add up to make 5. So I'm actually going to put a positive 3 in this guy and a minus 1 there. I think that works. 2x squared plus 6x minus 1x, and then negative 3.
Plus
Okay.
6x
You
minus
lost me
1.
on that one.
Okay? I'm just foiling this back together, right? Do a quick. So 2x times x is 2x squared. 2x times 3 6x. Negative 1 times x. Negative 1x. Negative 1 times 3.
-30.
Negative 3. Still not seeing it?
I am.
2x squared plus 6x minus 1x minus 3. Isn't that the same thing that I started with?
Yeah.
So do you see how I was just checking to make sure my factors were correct? I'm checking to make sure that my factors multiply back together. Okay? So now, do you think I can factor any further?
No.
No, these are all linear factors. That's a linear factor, that's a linear factor, that's a linear factor. There's no greatest common factors, so you would be done. The direction said to factor this completely if 7 was a 0, so I went through a little bit of a thought process, did some division, and did a little bit more factoring, but that would be my answer. Okay? Questions? I'm combining a lot of things there, all into one problem. Okay, we're still a little ways from having to do this. We're going to break it down into individual skills here just a little bit, but thoughts? What if the directions changed and said, find all the zeros? Just means you just have one more step, right?
Yeah.
What do you do with every factor?
Some equal to 0.
Set them equal to 0, and you'd get 7 is a 0, which we knew already. Positive 1/2 is a 0, and negative 3 is a 0. Okay? What's the degree of this polynomial? 3. How many zeros do we end up with? That's always going to happen. Whatever the degree is, that's how many zeros there are. That's the fundamental theorem of algebra. So that's something that we'll also use over the next few class periods. Okay? All right.